Return to prime numbers. We are given an even number n. Okay, we are given an even number n which is greater than 2. Return to prime numbers whose sum will be equal to given number. There are several combinations possible. Print only the pair whose minimum value is the smallest among all the minimum values of pairs, and the print the minimum element first. Okay, so we will be given a number. Okay, we will be given a number and we need to find two prime numbers which is less than or equal to n. Okay, which is less than or equal to n such that their sum is equal to this n, and we are having a particular prime number which is the smallest. So there will be many pairs that will be available, and we need to select that pair which is having the very smallest number with us, and n minus that smallest number will be the other one. So in this case itself 74. Okay, let's take 74. So what are the possible prime numbers for this 74 which is less than or equal to 74? Yeah, so 2, 3, 4 is not a prime number, so 5, okay, 7, 8 no, 9 no, 10 no, 11 is a prime, 12 is not a prime, 13, 14, 15, 16 not a prime, 17, 18 no, 19, then 20 it's not a prime, 21 is not a prime, 22 is not a prime, 23, yeah, 23 is a prime, 24 is not a prime, 25 is not a prime, 26 not a prime, 27 is not a prime, 28 is still not a prime, 29, yes, we are good with 29, 30 is not a prime, 31, yes, it's a prime, 32 no, 33 no, 34 no, 35 no, 36 no, 37, yeah, 37 is fine, 38, 39, 40, will we get 41? I think 41 is a prime. 42 no, 43, will we ever get 43? No. 44, yes, 45 is possible, 46 is possible, 47 is also prime, 48, 49 no, 50, 51, 52, 53 we can consider as a prime, 54, 55, 56, 57 is a prime, 58, 59 is not a prime, 60 is a prime, 60 is not a prime, 61 is not a prime, or 61 is a prime, yeah, 61 is a prime, 62 is not a prime, 63 is not a prime, 64, 65, 66, 67 is a prime, 68, 69, 96, 15 it's a prime, 70, 71 is not a prime, so 71 is a prime, sorry, 72 is not a prime, 73 is a prime. So these are the prime numbers. Please forget about any mistakes, like might include some numbers which is not a prime. So consider these are the prime numbers that are less than or equal to 74. Now we need to consider two numbers, say x and y, such that x is the very minimum pair which will be possible. Yeah, okay. So this the peculiarity of this x and y is that x plus y is equal to 74, and this x is the very minimum, so here the y will be 74 minus x. So yeah, that's what we need to actually check. Okay, so that's what we actually need to check. just find the very minimum value, then x, then 74 or the target minus x will be the other number. So that's all what we need to do. So we can just go through every number from 1 to 74 and can or we don't want 1. Why we need 1? We only care about 2. So from 2 to 74, and we can just check whether 2 is a prime. If it is a prime, then whether 74 minus 2 is a prime. So like that we can check, and those two values will be the first that we are getting will be the answer. And one thing it says is a solution will always exist according to Goldbachs conjecture. So Goldbachs conjecture means like any even number can be represented as sum of two prime numbers. So that's what I understand for Goldbachs. So if we are able to find any prime number x, then target minus, then say t minus x will be the other number. So that's what we need to do. Now we actually don't want to fully consider this whole 2 to 74. We only just need to go for 74 by 2. That is just by finding from 2 to 37, because if we say here the answer are 3 and 71. Okay, so we check 3. So 3 is a prime. So then the other number is 74 minus 3. So we don't want to go and check until 74. We just only need to check until the middle of the number, 74 by 2. So that's it. We can try this. So if as I told, like we can start from 2 until n by 2 and I plus plus. Now if we find if prime found, and if you find I as a prime, and that if prime found of n minus y, because there can be some other number also, like if it's a prime, then we can also just have a check whether the n minus I is also a prime. Then if this condition occurs, this is the first time that we will be encountering it, and that I will be the very minimum. So the very minimum values, like we need to print only the pair whose minimum value is the smallest among all. So if we first find this condition true, then this I will be the minimum, because we are going from I to n by 2. And we can just return arrays dot as list of new integer I and n minus I. Otherwise we can just return an empty array list. That's what we were asked to do. Okay, and actually we don't want to actually this case will never occur, because according to the Goldbachs conjecture, like a solution will always exist. Now we need to write the condition for this is prime found. So here, like we can do the normal check, like the normal prime or not prime check, which is having a time complexity of big of root n, or we can also implement C of Eratosthenes. But here we can just go for the normal prime number check, and that will be sufficient. So static boolean is prime found for number. Okay, so it's pretty straightforward. If for int I is equal to 2, I into I is less than or equal to number I plus plus. If number mod I is equal to 0, this means that number gets divided by some other number, but a prime number, which violates the property of prime number, because prime number will be only divisible by that number, that same number, or by 1. But here we get some other number that gets divided. So we'll be returning false. Otherwise we can return true. Okay. Okay, let's combine. So this will be big of n into big of root n, big of n into root n. Okay, that's static boolean is prime found if sorry, is my typo. Okay, is prime found. So 3 and 71, we got the first one. Let's submit. Yeah, that's the idea of this problem.